Alright, I see a few more students have posted on this discussion board. Make sure that you have done that. This is really how we are going to create content or have a repository of some resources that you can use to grab help from. You're always welcome to ask me, but sometimes there's other resources that are actually, in some cases, better. So make sure that you're posting on the discussion board. So in the next couple of weeks, one of the things we're doing is you're having to create a, to do that, exit going. You're having to create a website that you're going to use or materials on your own page. So if you will join me in going to python.org, we're going to go over downloading this one more time on how to download and install Python. So if you're in the classroom here with me live, I'm going to go through it, but I'm going to ask you, we're going to do a little different one, but it's very, very similar. So python.org, as you wander around here, this is really everything from, if I'm skilled at Python, how to find jobs. There's a community, so that community includes discussion boards and all different kinds of things. So it's kind of an interesting piece to go to. But what we really want to do is we want to download Python. Now, as I said in here, because I do something a little weird, I'm going to grab a slightly different version. For almost everybody else, you can grab the 3.10 version, with one big exception. If you are still using Windows 7, which weirdly you'd think, hey, Windows 10 has been out now for many, many years, and they've actually replaced it with Windows 11. Why would I still be running Windows 7? Well, on a lot of corporate networks, there are still a lot of computers running Windows 7. All right, so I'm going to go to the Windows area, and I'm going to scroll down here a little bit, and notice it will let me show stable releases and even pre-releases. So these are not yet ready for prime time. So what we want is a stable release, and I'm going to look at the 3.9 version, and I'm going to do the 64-bit. You can run the 32-bit, doesn't really change a whole lot. I just prefer, I'm on a 64-bit computer, to grab the 64-bit package. So this one here, we're going to look and say, all right, here's the Windows installer, 64-bit. It downloads in a matter of seconds. It's really, really very small. Once I download it, because I've already had this in here, it's going to ask me a question. In this case, it's going to let me uninstall it, repair it, or modify it. I'm just going to quickly do a repair. If it's the first time you've done this, this would be doing the complete install. And quite frankly, all of the defaults you can use. So we don't need to do anything strange with it. It can work with all of the defaults. Keep going. Alright. So it doesn't take a long time to install. And the way we invoke that is on the start button, the key phrase is IDLE. So it's a development environment. So if I type IDLE, I get very quickly, I get the script or the shell mode. So in this case, I could do things like print. It still doesn't help my typing prowess, and it will actually work interactively. But what I want to do is I want to go a little beyond that, and I want to use the batch or script mode. And so I'm going to type File, New, and it's going to open up what looks like a text editor of some sort, and it is. And we'll show you some as we go along that are actually far better than this, but this is so in this particular case, what we're doing is we're creating those .py files. So if I were to file and save this, I'm saving it as a .py file, but what I need to do is I need to know where I'm saving it. And by default, it's saving it inside its own folder, which is not probably a great idea. So I'm going to make a folder under Documents here, and I'm going to save these documents inside of it. So I'm going to make this a little bigger so you can see where I'm at. So I'm on My Documents on my computer. I'm going to make a new file called, and I'm just going to call it Python file. If you are working in multiple locations, a flash drive might not be a bad way to do that also. That way you always know where your files are at. So if I'm storing files on my flash drive, I know that that's where they're at and I can carry them with me. In the computer lab, anywhere on our campus, or if you're at a library somewhere, the danger always is that those files are going to get changed or somebody will grab them, whatever the reason. So I just like to throw them on a flash drive, or in this case, because I kind of own, quote unquote, this computer, or the use of it, I can actually store them wherever I am. So this I'm going to call my sample, and I'm going to save it. Now, there's nothing in this file that's actually going to run, but I was able to save it because I put a little bit of content in it. So I'm going to go look in my File Explorer. I'm going to go to Documents, Python Files, and there is my file. And it'll actually, if I click on it or hover over it, it'll tell me, hey, it's a Python file. Windows now recognizes that that is a Python file. And if I were to go to details, you'd see it has a .py extension. So if I go to Properties, it's got a .py. Here's the one thing that I will ask those of you that are on a Mac. Yours looks similar. However, the Macs are a little smarter than Windows PCs in some regards. You will probably have to manually put that .py extension on there. And there's two reasons that you have to do that for me. One, I'm on a Windows PC primarily, and it's not very smart. So if it sees a file without an extension, Windows doesn't look into the file to actually see what it is. It just says, I don't know what the heck it is. Reason one. So you might have to manually put .py as an extension. The second reason is with our security software that we're using and on Blackboard. To upload files into Blackboard, you're going to find that sometimes things don't work as we intend. We've made an exception for .py files, and a file that isn't or doesn't have that extension may not get uploaded correctly. So we always want to call it a .py file. So this editor, if you notice what it did, so I said File, Save As, it should be in the same location. It automatically says, hey, it's a Python file, it's going to give that. If I put as all files or text files, I would actually have to type like sample.py to make sure that it's actually in there as the right type of file. So Python files are really nothing more than a text file. Alright, so my next part then is if I need to upload this into Blackboard, I need to make sure I know where that file is at. So that's why I'm very careful here, make sure I've created it in a spot that I know where it's at. The other thing that's different than the sandboxed environment is I can run this, so there's a lot of different options up here. So I can run this module, and notice it runs over here in this idle shell, even though it doesn't do anything. So I want to modify it, so now I'm going to say, oh, I need a print statement in there. And notice it does a couple things. It doesn't automatically in this shell give me the first and last parentheses automatically. I have to make sure that those are in there. It does color code things. So text is always green, and if I miss this ending parenthesis and I go down to the next line and I was like, oh, I need a second print statement, it will yell at me at some point a little bit. But it's not got a lot of editing capabilities. So I'm going to save this because I can't run it unless I save it. So let me run it. Oh. And it doesn't even give me an error code because it doesn't have anything existing there that really is an issue. Alright, so I changed it. I want to run it again. And notice it always says, hey, I have to save it before I can run it. Alright. So this is kind of like when you're working in your web design class. You always have to save it before you run it. So that's where the two monitors comes in kind of nice, because you can have an output area, so I could put that on one window, and then my coding window in another window here real quick. So that's what the Python editor looks like. Now, I can open this file. So I can click the open with, and I could actually open it with Notepad. And if you look at it in Notepad, it looks exactly the same. It is truly just a text file. So I can manipulate it inside a Notepad, or if you're used to using another, if you're on a Linux machine and you're used to using VI or something, you can actually do it with that. But this one's built right in, so it's kind of handy. It does have some limitations, and we'll talk about those as we go through. So we don't do a lot of serious coding with this. Honestly, if you're working at a company that's writing Python code, you're going to use something a little more powerful. But this is the free, this is what you get version. So run has a couple of options. So you can actually check your module, and it'll say, all right, I don't have an error yet. There are other options that you can do. So I'm going to probably change my zoom height and a couple of things as we go through the class to make it easier to see. So you can get some information. There's help over here, and this will launch somewhere. So a Python documents folder if you want some help. So it will also have all these pieces. So if I want to learn about time, then now there's a lot of information about it. But again, this isn't necessarily the most user-friendly, so I might want to use another resource for that. So file and save are really important. Edit does have some interesting pieces in here where if you want to replace something, the replace option, so I notice I've spelled something wrong. What is going to become very important to us very quickly are these indent and dedent. So Python is a language based on not only the words, but the indenting. So when we start doing some other functions, you're going to see these indents become very, very, very important. So that is our environment here that we're going to create an assignment for you with this week. So come back out of here. I'm going to close this out. So again, to get to it, IDLE, and it'll pop up on your screen. So you can also find it if you look through and you go to Python. Junk on here already. Notice there's different environments here. There are some manuals and some docs and things, but this is what we're really looking for, is this idle environment. So, all right, let me go back to too many windows open here. All right, so let's talk about what we're doing this week. So last week, most people did really, really well on these assignments. 1.6, I had a couple people struggling a little bit, so I'm going to look at that really quickly. So 1.6, come on, Python, there we go. All right. So the biggest issue I had was when I went through, I didn't do the radius squared. I just put in 3.14 times radius. And so if you actually went in to evaluate that, and I run my checks, you're going to see it doesn't give me. They'll say, oh, that doesn't give me the right output. Well, in our directions, it said, use the formula 3.14 times radius squared. So, area of a circle is pi r squared is the way to remember it. Pi r squared. So, I didn't square that radius. So, a couple of ways you could do it. You could simply multiply it again. So, if I did that, and I run it, and I put in a value, it's going to say, all right, that's 3.14. And so now if I go to do my checks, it takes these inputs, it creates a couple of different inputs and says, okay, you've got the correct output. Is there another way to do a squared function? So, well, maybe I don't know. So I would say, let's do a search for Python square function. And let's see what we find. How do I square a number in Python? Well, let's take a look. So, the power operator, aha, so 2 asterisks gives me a power operator. So we have a power function. We don't need to necessarily use that, but that function here using 2 asterisks or 2 time symbols might be kind of handy for us in the future. So maybe instead of saying, I could do this. So we're taking it to the second power. Let's run my checks. Does it give me the right answer? Come on, send good. And I'll say, oh yeah, because there are multiple ways to do the same assignment. So if I run this, I should get an answer that makes sense. So radius squared. Well, where this is handy to know this, what if I actually want something to the 3rd or the 4th or the 5th power? I can do that. I can also maybe, let's just see what happens. Let's just see what happens. So I'm going to take radius, and I'm going to take it to the 0.5 power. Hopefully if I put the cursor in the right area. Because now I got to thinking, wait a minute, can I do square roots and multiple roots doing the same thing? Well, I'm going to run it, and I'm going to put in a number I should be able to calculate. Oops, put the wrong button. That I should be able to know the square root of. So I'm going to put in 100 again. 100 should output 10 if we really are getting the square root. And it gives us a value, so it printed that, but I never assigned it to an area. So we have to make sure that you're getting in the right thing. So just an example of how we can use some of those in different ways and how sometimes it's kind of handy to experiment. Everybody that did 1.7 seemed to do pretty good, if I remember correctly. And this is where where you put in your age, and I went through a lot of that in class. So I will now, if you did not do any of those, I gave a couple extra days, but we're going to clear those out and zero out those assignments then for week 1 and 2. So go back to week where we're at currently. So we looked at this case study. It's not a bad one to go back and look at. And the case study directly involves 2-1. So hopefully everybody has an idea of where we're at on 2-1. Go Cengage. Come on. Aha! So, you can calculate the surface area of a cube if you know the length of a cube. So the surface area of a cube. So how many sides are there in a cube? First, we might want to design this program a little bit, and we might want to think about it and use this pseudocode that we're starting to learn. So pseudocode really is just English, and we're saying this is what our program is going to do. So in this case, we're going to say, oh, we're going to input in the length of an edge. Well, then we need to know a little more information about what we're doing. So, if it's a cube, all those sides are equal, correct? All the lengths of them. So, to calculate surface area of one side is equal to length times length. So that would give me the surface area of one side of a cube. Surface area of cube is 6, because there's 6 different sides on a cube, so think of a dice, times surface area of one side. Output surface area. So that pseudocode really is just our way of breaking down that problem. So if I'm in a math class and I'm asked to do this, this is the same thing my brain would be thinking and the way I would try to calculate that. So we need to get a couple of things out of our users. And so we have a test value we can run to make sure that it actually works. So I'm going to take this pseudocode and I'm going to flip that into Python. And one of the really nice things, Python and English are so alike that I can usually do a very quick job of converting from pseudocode or my algorithm into the actual code. So I might want to even make a surface area is equal to 6 times surface area one side. So just some notes for myself. I know I'm going to input, but I have to assign it a variable. So I might say length equals input So now I've got a value for length. I can modify that, and I can calculate then surface area equals, so I know that this is going to be then length. Now notice I misspelled it, that's great, but I'll fix that. Times, or I can square it, either one. And because I want to make sure I do that function first, I'm going to put that in parentheses. And actually, order of operations would mean we get exactly the same number, but just to make it clear, times 6. And then I want to do a print statement. The surface area of your cube is surface area square units. So this should take in our length. It should square the side, and it should then calculate out a response that is appropriate. So I'm going to run this, enter the length of one edge. Well, I know that my test case is 4. Oh, wait a minute. What have I got going on? Unsupported types for, wait a minute. Oh, so notice my input. I didn't convert that to an integer or a float. So just in case somebody is maybe putting in a float value, so they're saying our cube's edge is 4.5, I'm going to say length equals length, or float of length. Alright, so that should fix my problem. Let me try it. I'll put in 4 again. So what is it? Why doesn't it like that? Is it not like float? It says it's an orange word, so let me come in and type integer and see if that works better. And I get a syntax error again about this statement. So usually what that means, let me close this to make it a little easier. Usually what that means is we actually need to look at the line above it in most cases. So notice what's missing up here. I didn't put a closing parenthesis on there. So now if I move this back so I can run it, 96 square units. Alright, well, now I want to try it with a float to see if I get a weird answer. 4.5, 121.5 square units. So, a couple of different ways you can do this one. I will say one of the difficulties, depending on the size of your monitor, is you have instructions and your coding and this terminal all kind of squished up. So these sliders are kind of nice because I can slide around where I'm at. And again, depending on the size, if it's good or not. So, alright. So I'm going to go in here to check this one. Run checks. And it's going to test out a couple of different numbers in there. And it gives us that 100%. Yay. So I am going to submit that. And make sure, so one of the issues I have had is a couple people go, oh, yep, it's already done. Make sure you hit that confirm button. I've had some people not hit that. I can't see that your work is submitted because it doesn't actually send it then to the right location. Alright, so we've done 2-1, 2-2, and we'll take a look here at 2-3. Come on. Alright, so first thing I always put my name in there. And then I need to think a little bit about the problem here and probably write some pseudocode to figure out my algorithm. Alright, so 5-star retro video rents tapes, VHS, and DVDs. Oh. To the same connoisseurs who like to buy LP records. Store rents new videos for $3 a night and oldies for $2 a night. Write a program that the clerks at 5-star retro video can use to calculate the total charge for a customer's video rentals. The program should prompt the user for the number of each type of video and output the total cost. Okay. Sounds fairly clear. So I'm going to go over here to my notepad and I'm going to think about what information I know. So I know that I'm going to have new videos going to be equal to $3, right? And old videos are going to be equal to $2. So I know that already. And so I know that I'm going to have to input number new videos. I'm going to have to input number of old videos. And then I'm going to have to come up with a way to create a sum. So the sum would then be equal to number of new times my $3 or whatever it is, plus number of old times $2. So, does that make sense? We have to find each section, add them together, and figure out how much our cost is. So there's a couple of lessons we're going to learn in here, I hope. So as we go through here, I'm going to show you what might come up as an interesting revision. So I'm actually at the very beginning of this program. I wanted to find my variables, and I think that will help us in this. So I'm going to use just old and new. So I'm going to say old and when I use all capitals, that tells me that that's a constant. It's not going to change during my program. Old price equals 2. So I'm setting those variables, old price and new price, at what they are. My next variable is going to be something like, we could say number old, and we might say number new. That way we can get a quantity of those. And just as a garbage check, I'm going to go ahead and put in 0 in all of those. So it just makes sure that it's closed out. All right, so now I've got all my variables, I think. Oh, wait, I need the sum. 0. Now I've got all my variables in there, so I might even put begin main program. So now I've got all this information up here, and I need to convert that into something useful down here. So the first thing I'm going to say is num. See, the program looks for new first. New is equal to input enter the number of new videos. Now, what I also probably want to do in one line is I could put that into a integer and convert it from text to an integer right away. Well, because I'm lazy and I don't like to type a lot, I'm going to copy this line and I'm going to put it down below. And I'm going to change this from old to new into the number of old videos. So I just changed a couple of things in here, and now I have a quantity for new and for old. So I could do this. So I could write sum equals, so we have number new times 3 plus number old times 2. And that's going to give me the sum. And I could print out a print statement like this. Print the total cost is then I'd print my sum. And I may want to put in like a $sign there just so it makes a little more sense. So I probably am going to have to put a round function and something else in there, but I want to try this right now just to make sure that works. So I'm going to run this. I'm going to put in, make this so it looks readable a little better. Enter, let me run it again. Enter the number of new videos. I have 3. And number of old videos, I have 2. Oh, wait a minute. Why is it giving me that value? That doesn't look right, does it? So I need to come back in here and take a look at my coding and see what's going on. So it's taking in a value here. And I noticed the other thing is I've got to make a space there because that's going to drive me crazy. All right, so new or number new equals that input here. So I need to do a little error checking and see what I have going on. So one of the things I like to do then is I put a temporary print statement in to make sure that, hey, am I getting the right value? Is it getting stored correctly? Okay? So I'm going to do the same thing after this one. All right. So now if I run this, I put in these error checking spots. Enter the number of new videos. Enter the number of old videos. What have we got going on that it's doing that? So we need to take a look at our code and try to figure out what's going on here. So num new equals the integer input of enter the number of videos. And then here I printed num new. So just to make life a little easier, I'm gonna use those tags, and I'm gonna take that out for a second. So all it's gonna do is it's gonna echo this statement. So I'm gonna move it back over, and I'm gonna try this again. So enter the number of new videos, 3. So why is 3 becoming 0? What is my problem with that? So let me move this over a little more. And let's see if we can do some error checking in here. Input the number of new videos, and num new is equal to that value. So maybe something isn't right with my integer. Let's take a look. And I'm going to take that statement out to start with. So my variable name, let's make sure it's right. So num new equals input, enter the number of videos. Where it's getting that 0 is we assigned it a value of 0. So we know where that's coming from. But why would it not change? What might I have done wrong here? So I'm going to run it again. Enter the number of new videos, 3. And it outputs 0. What's the problem in here? Does anybody see it yet? No. This one's very tricky. This one has to do with when I type this, look at this value here, and look at this value here. So it's case sensitive. And my brain, and these are hard to find because it looks like, hey, I got the right number, I have the right piece, so I'm going to run it. And now let's see if that gives me the right number. Aha! Okay, so I've worked my way down here. That works, so I'm going to delete that extra statement. And now I'm going to try to take this out. Num old. Oh, I did the same thing. Num old equals input of those videos. So I'm going to make sure that that function works now. So 3, 2, and it should equal, oh. And notice here, because I didn't ever define it, alright. So sometimes these things that you think are really easy, once you get in here in this coding, simple things like writing in whether it's capital or not can drive you crazy. So now I'm going to try this sum function again. And I'm going to try my print statement to verify it and see if this actually is going to work. Total cost is $13. All right. We're there, sort of, kind of. So let me check my run checks and see what it tells me. Oh, why is it giving me an error? That looks right, doesn't it? New 3, old 2. Result. Oh. So we're going to have to use our round function. So our expected output is 13.0. All right. So we have to do a couple of things in here to try to figure that out, right? So we need to figure out how we can round something. And if you're like, I can't remember, let's look at the round function. So I'm going to look it up, and W3 Schools tells me round the number to only 2 decimals. So we're going to take our sum, and we're going to round it. Okay, perfect. So we need to take our sum here, and we need to figure out how we can round that value. So maybe the easiest way is just do sum equals round and sum, comma, 2 decimals. See what happens. So it says, hey, we've got, why does that give us that value? So it says we need at least, or we can round to a maximum of 2. So we may need to do a little more thinking about this on this problem. More problematic to me, let's see what our run check says. We're going to have to do a little work on this to figure that out. So it says, puts in 5 and old of 5. Alright, so we're going to have to do a little thinking about our rounding statement, how that's going to work. But here's the problem I see with this. I took the time to make these constants up here. And down here, I don't use them. So the first thing I'm going to do is I'm going to change this to new price old price. And notice I can just grab them there and put it in, which makes it kind of nice. Well, why does that matter? Do we get the same result? So if I run this, I should get the same result. I still get $13, right? I need to delete that out of there. So I still get $13. Why would it matter that I did it that way? So I like to never hard code values in there. What if our manager comes in and says, all right, I know that inflation's hit, we need to change the prices. So instead of $2, it's now $2.50, and I change it one place. And instead of $3, it's $3.50. Yeah. So now, when I run this, I'm going to get a different result. But I don't have to find every place I've hard-coded that value, because I guarantee we're going to forget. So the idea of us being able to change that Yes, those are static values. They're static throughout the use of that program. They don't ever change. So now if I run it, so I have 3, 2, I'm going to get a cost of $15.50. So maybe I come over here and I say that those are set to, and now I'm going to run my checks. Oh, look at that. Notice the difference? The reason is, when I set those as just 2 and 3 and use them, it says here's an integer, and I said this is an integer. So I don't necessarily need this as a float. I can't take 2.5 tapes or 2.5 DVDs. So integer is fine for this. But my price, because it's a dollar value, I probably should make that a float. And that's what I did by explicitly saying it's got decimal points there. And when I multiply a float times a integer, it automatically makes it all an integer. So now I have a program that I have the prices in here. I can change them at any time, which is kind of nice. And it will still give me the correct sum. Or does it? What other items? So when I look at this, I say I want to expand this program a little bit. What other things do we have that's horrible around us when we purchase something? If I go to Walmart and I buy $100 worth of groceries, do I just hand them $100? Or do I end up with something else in there? What about our sales tax? So, I want to expand this program a little bit, and I want to add sales tax in there. So here I have sum is equal to that. Tax equals sum times, and I'm going to pull up my sale tax. Notice here, I'll just click on it. Sum times sales tax. And then I'm going to say sum equals sum plus tax. So now I can put in sales tax in there. Now, our program doesn't require it to do this. What I'm showing you is how easy it is to add additional functionality. Once I have some core pieces in here, then I can start making it pretty. I can start looking at how do I make it more functional? What other pieces do I need to add? And so to truly follow the rest of the things that I've done, I really need to have tax equals 0 also up here. And that way I've made sure that there's no garbage setting in there. So now if I run it, 3 videos, 2 old videos, and it's going to say, hey, your cost is $13.91. So sales tax is always fun. And if tax changes, which it often does, so if it changes to add a half-cent sales tax, like what we're talking about in a lot of cities to add, all right, so now if I run it, I get a slightly different number, so I'm going to have to do something different. So here where I rounded it, maybe I need to round it again so that it'll work fine. So I rounded it here, but we multiplied it times that sales tax, so I need it rounded here again. And $13.97. So that round function is really nice. What we used to have to do with a lot of languages is we could truncate off a value at a particular number, but we had to then add values into it to make it automatically round and such. And we don't have to do that with Python. Excuse me. Excuse you. All right, so now if I run checks, it's probably going to give me an error because it's going to go, whoa, you got all this extra stuff in there. And it did. So I put it in there just to kind of make it a little more real world. But notice what I can do. I can take those out. Oops, hopefully I hit it. And now if I run the checks, it should actually pass all of those again. So 100%. So now we've created a whole program. Now, I obviously added some other pieces in there, and it's going to give you a correct result whether you just multiply times a random value in here or not. I don't like random numbers in my programs. It's just kind of the weird way I am. That way, it also makes it easier to change that very quickly. So if the tax goes to 10%, I don't have to change anything. So we want to change now $4 for an old one, because we discovered that people like vintage stuff, so they're going to pay more for an old movie. We can change those prices in there, in the whole program will function with us. All right, let's take a look at one more really quickly. 2-3 as it loads. Again, almost always we want to start these with that idea of that pseudocode, that kind of our thinking out of the box. Sometimes I just write this on a piece of paper. Oops, did I grab the same one? I did, didn't I? Chunk. Okay. Go Blackboard. Go Cengage. Hang on. At some point I'll manage to click the right one. Come on. All right. Write a program that takes the radius of a sphere, a floating point number, as input, and then output the sphere's diameter, circumference, surface area, and volume. Ooh, yikes, we got a lot of pieces in this. So, for convenience, you probably should import the math module. All right, so I'm going to put my name in here again. And I'm going to start to think about what I need to get out of here. So, I know I'm going to input a radius as a float. All right, so I know that. And then I need to calculate a couple of things. So diameter equals 2 times radius, circumference equals diameter times pi, 4 times pi times radius squared, 4/3. Okay, so I have all these different formulas. So diameter equals 2r, all right. Circumference all right, so how do I get diameter from radius? So radius times 2 is equal to the diameter times pi. Then I have one here that says, so my area is equal to 4 times pi times radius squared. All right, and finally we have our volume. Times pi times radius cubed. Oh, all right. So one of the things it says is we could probably import the math function. So import math. All right. So I'm going to take this, I'm going to think about it, I'm going to drag it over here. So the very first thing I know is I'm going to import math. So, great, we get the math formula inputted. Now we can use, so remember I can do pi. So math.pi will give me a value of pi out to 15 digits or whatever it is. All right, that's kind of handy to have. So that might help me a little bit. The next thing I need to do, though, is probably come up with my variables. So because pi is coming out of math, I don't necessarily need that one, but I am going to use diameter equals 0.0. And notice that sets it as a float automatically. And I'm going to shorten circumference, maybe. Nah, type it all out. Area, well, probably should do it surface area. And volume. So there's another advantage to a lot of text editors is once I create these, I'm able to utilize them really quickly and not screw up the spelling. So I'm going to begin my main program. So the other piece I need is radius 0.0, because that's what I'm going to input. So radius equals float of input please enter the radius. All right, and so it's going to convert whatever we take in as a string into a radius, or into a float. So now I can work on some of those. So I could say diameter equals 2 times radius. All right, so I could just leave that formula in there and say 2 times radius, and I have my diameter. So what does it want me to do? Aha, so we're going to do all these. But notice what it's doing. It's putting all those decimal point or the colons at a specific spot. Yeah. How can I do that? Let's think about that just a second. So I'm going to come down here and put output area. So I'm going to do a print, and it wants me to print the radius, and it wants me to print these different values. All right, so print diameter so remember those escape characters we looked at before, right? The backslash. So a new line, that's not going to help me. But what about that tab? So what if I did 2 tabs over and then a colon? Diameter. All right. So I'm going to run this now, and I'm just going to see what I get. So no expectations yet. And if you're not trying these as you're building them, then I'm going to. So please enter the radius. Diameter. So maybe I didn't do that right. Well, let's go back. Oh, there they turn red. Got to remember to use the backspace, so try that again. Oh, notice it puts it over there a ways. Maybe 2 of them is too much, so maybe I'll take out 1. And now I'll try it again. So I made my output a little better, so I can control where that's at. So 1 tab over. All right, so now I've experimented a little bit, and I know that I actually need to also print equals radius. So now, what I also know is then I need to start a new line with this. So a couple of different ways we can do it. So let's do this. Let's see what happens when I run this now. So I'm going to enter my radius. It says radius equals 10. but I want a line between radius and diameter, and I kind of want to scoot this down from my input also. All right, so before I do this radius, what happens if I did so I put in like 3 lines in front of that. What is that going to do for me? So let's try it. Oop, what did I do? Type something wrong. Oh, I put it outside of that. Now let's put it inside the parentheses where it belongs. So now I put 10, and it jumps down. Oh, all right. I think I got this then. So after it prints that, one way I can do it is I can put then that backslash in right above it. So now, let me run this. So 10, radius equals 10. Oh, look, and it puts that down there nicely. All right. So we're starting to format that a little bit. And so now the rest of this is really just following those formulas in there and creating the rest of my content. So it wants several different pieces, so I'm going to pick the hardest one maybe and do that. So I know I have to do a circumference, I have to do a surface area, but I also have to do a volume. And notice I get the value, and I got to follow this formula. So 4/3 times pi, so 4 divided by 3 times, and I don't necessarily have to do, put it in parentheses, but it makes it a little easier to see this, times math dot pi times radius. Now, I could say radius times radius times radius, but we have our handy-dandy exponent function, so I could take it to the 3rd power. And look at that. 4/3 times pi times radius cubed. All right. So I need to put it down here. So print volume equals, so I can run this now and try that, make sure I've typed everything right, which I probably haven't. So 10, radius equals 10, diameter equals 20. All right, that's pretty easy. Oh, what have I forgot? I did not put in that tab. So let me go back in and put that tab in there and change this a little bit. So now let's try it. So here, because diameter is longer than the value of that tab, that first tab, I'm going to have to maybe put in 2 tabs. So it is going to take a little bit of experimenting. So, oh, look at that. Now, I apparently have added some space in there, so I probably want to take that back out so it goes to the right line. Chunk. Now, you may also want to think about, and I'm going to go back and look at my directions real quick, takes the radius of a sphere. So its output, it shows it is just continuing on. It doesn't round any of it. So in this case, we don't necessarily need to round it. But if we did, we know what we could do. We could say we want to do, so volume equals round volume. So maybe we wanted to round it to 5 decimal places. And it would take it in then and round that off a little bit. So we don't necessarily need to do that for this program, but it's just a thought as we proceed on. So I'm going to check a couple things. So I want to run checks. my guess is I'm going to get part of that right. And it's going to say, oh, test case. And we can actually see what it's going to tell me. So please enter the radius of 5. Radius of 5 equals diameter. And so what it should do is give all of those pieces. And I did not put all of those in there. So you're going to have to go in, add those other 2 pieces at least, make them all fit, and then submit that for a grade. All right. I will actually create a video for the Python assignment, so you'll see that coming up shortly. Please be working on these. If you wait until the last minute, this tends to make people sad because those silly errors like where I had volume, old and new, those kinds of really simple errors are hard to find, especially if you're under other stress. Sometimes the best thing you can do with coding is walk away for a minute. And I know that sounds counterintuitive, but the reality, sometimes our brain gets stuck. And so walking away, going and getting a cup of coffee, taking a quick walk, playing with your pet, whatever, can sometimes actually be advantageous. So if you get stuck, look at it for a minute and walk away for a second. Relax the brain a little bit. All right. I am going to end this video today, and we'll add the one about, and I'll send you an announcement about the assignment for using Python and IDLE outside of this sandboxed environment.